In this video, I want to go over how you could implement hybrid search in KDB.AI. Now for this one, let's go straight to the code. Let's not mess around. But first, I want to give a quick refresher on what hybrid search is. So hybrid search is something like this, right? When you're doing a hybrid search, instead of just doing a regular dense search on our dense embeddings, what we're going to do is we're going to generate a sparse vector, and then we're going to generate a dense vector, well, at the same time, and we're going to search both simultaneously. And then we're going to re-rank with an algorithm called reciprocal rank fusion. Now, there are different algorithms used to re-rank, but reciprocal rank fusion seems to work pretty well. But that's something you can experiment with. So let's implement this. And the way we do that is we're going to install the KDB.AI client. I already have it installed. Let's install some extra packages. I already have these installed, so I'm going to skip that step. Now let's import them. Let's import some libraries, and let's add some data to our environment. Next, let's use LangChain to actually load some data and split it into chunks. And then let's create a data frame with this data. And now what we're going to do is we're going to use a tokenizer to create our sparse embeddings. Now here we're using BERT tokenizer fast, but you can use whatever tokenizer you'd like. And let's also import some transformers. And we're going to use this all mini LM L6v2 embedding model in this case. Now let's instantiate it here. So this is going to take a little bit of time. But okay, it's done. Now, next, for every single chunk, what we're going to do is we're going to generate a dense chunk, a dense embedding, and then we're going to create a sparse embedding, sparse vector. And what's important to note here is that our sparse vector is generated with this BERT tokenizer function, right here. And there's some things that we need to note here. For example, we're saying add special tokens equals false, because what this tokenizer does is if you don't add this, it adds extra tokens at the end, right? So what we're going to do here is we're going to compare, this code is equivalent to not passing that parameter and then deleting these extra tokens. Now let's do this and look at what this actually looks like, right? So we have our dense vector and we have our sparse vector. And if we look closely at the sparse vector, this is actually a dictionary, right? It's a mapping of every single token. This is a token and how many times it occurred. And that's what this code here is doing. It's counting every time, how many times every single token occurred for token in the chunk, right? And what we end up is a bunch of sparse embeddings, some dense embeddings, and then we're ready to insert that into KDB.AI. So let's do that. I already have my environmental variable set, so I'm going to connect to the session. And next, I'm going to look at my databases, see what I got here. Okay, I got some databases, and let's delete my database and create it. Next, let's instantiate my schema. So my schema has an ID. It has our chunk, which is going to be text. And it has additional columns of sparse and dense. And what's important here is sparse is of type general, right? That's just something that you need to set in order to add a sparse vector. Now let's define our indexes. Our indexes are going to be a flat index, which is going to be used to search our dense vectors. And we're going to create a BM25 index to search our sparse vectors, right? So this relates to the names here. So we have a name of dense and sparse, and the column is exactly that. Column is dense and sparse. And for our sparse vectors, we could also set these additional params of K and B. Now, if you remember my other video, that goes into hybrid search, you'd know that these are not very important. But these are hyperparameters that you can set if you need to. And you could set them when you create your table, or you could change them at runtime, at inference time. Okay, let's make sure we run this cell. And now let's list all the tables in our database. We don't have any tables. So I'm going to create an inflation table. And now that I have my table created with my schema and my indexes, I'm going to look at my tables, make sure it's in there. Okay, I have a table called inflation. And okay, we have this index defined. So we have these indexes defined. We have our dense index and we have our sparse index. And then we can find out stuff like our dimensions here. And finally, let's insert our data into our table. Okay, we've inserted 43 rows. We can visualize them here by querying our table. And we see that we have our sparse vectors, we have our dense vectors, and we have our text, and we have an ID. Perfect. Now, let's actually perform a hybrid search. And our query here is 12-month basis. I want to learn more about this 12-month basis. So in order to make a search, I'm going to follow a very similar process to when I was inserting the data. I'm going to create my dense query, which is just going to be a dense vector. And I'm going to create the sparse vector with exactly the same code. Here, we're actually manually removing these two tokens. Let's actually look at this. I feel like this would be useful. Let's print this sparse query, and you'll see what it looks like if we don't have the extra parameter that removes the special token set. And let's look at this. So here we have this extra token here, 101, and this extra token here, 102, at the end, right? And that's what we're deleting here. So if we print sparse query now, oh shoot, then that should be gone. And these are just end of phrase, start of phrase tokens. They just don't give us any additional meaning, so we just remove them, right? These other tokens actually have meaning. They come from this 12-month basis query. So next, let's set some pandas options and actually make a dense search. Okay, so I've made a dense search, and I'm only searching on the dense index here. And I'm grabbing the ID in the chunk. And I see that we have some results, but we don't actually have the actual keywords 12-month basis here. I don't see it. It's nowhere here. It might be in one of these, but it's definitely not in the first one. And let's search with only our sparse index. The cool thing about KDB.AI is you can make these individual searches, or you could search both at the same time and perform RF. That's what we consider a hybrid search. So here we're doing a sparse search. And as we can see here, we have 12-month basis. I don't know if you can see, we have 12-month basis here in our first result. And you should see it in the second result as well, third result. So we're really prioritizing the keyword. In fact, we're only looking at a keyword search. Now, let's combine the results with RF. And when we do a hybrid search, we could set a weight to every single index. So here we're assigning a weight of 0.5 to our sparse vector and 0.5 to our dense index. Sorry, sparse index and dense index. Now let's actually do the search. And let's see what we get. Okay, great. Suddenly, we don't see this 12-month basis in the first result, but we see in the second result. It's right here. And that's because we're giving about equal priority to both indexes. Now, we can go more deeply into how this RF algorithm actually orders stuff, but at a high level, it gives them about equal priority. So the beauty of this is a keyword search or a sparse search is going to return very different results from a dense search. Extremely different, right? Because the way they work, one is semantic, one is keyword. And then when we hybrid search, we can re-rank. But what this does in practice is it massively improves the recall. Because by using these two different methods to search, we can massively improve recall in practice because every single one of these methods misses results on the other side, right? And then we have a re-ranking strategy. And here we have RF, but we can, of course, use a re-ranking model that is a little bit more robust on top of that, or whatever re-ranking we have in our search pipeline. But the hybrid search basically improves every single search pipeline because it improves recall in that first place. Even if you have the perfect re-ranker, you can't re-rank a result that you didn't fetch in the first place. Awesome. So we have this result, and we can also apply different weights. So here we're applying much more weight to the sparse index than to the dense index. So we should get it 12-month basis in the first result, and we do. And let's give a massive dense bias, and then we might not get 12-month basis in either of the first two. No, we don't get it, and I don't see it. We might not even get it in the third. Okay, we don't even get it in the third. All right, we could also do a little bit of hyperparameter optimization by setting B and K at inference time. Now, it's very rare that you would actually do this in practice, right? It's very rare that you need to set B and K at inference time. But let's say you have a lot of different data, and you know that for certain queries, you've identified that a different B and K is going to be better. Then you can actually set it at inference time. But it's very rare that you would do this in practice, although it's a good to have. So let's try it with a different B and K, see what we get. So here, massive dense bias. We don't get 12-month basis in the first result. Yeah, so this is something that's good to have. Now, one thing to note with KDB.AI that's interesting is when you insert new data into a KDB.AI table, all underlying BM25 statistics are updated. So you don't have to worry about making sure that your BM25 statistics are updated. Just insert the token counts, and we're going to update everything for you. And this just makes it much easier to maintain this in practice. All right, that's it. That's how you implement hybrid search. With KDB.AI, you could actually have more indexes. You could have like several sparse indexes, several dense indexes, and with different embeddings of different sizes. And then you could re-rank with custom priority for each. Or like if you're doing A/B testing, you can have several different dense embedding models and just try them, right? All in the same table. And that's amazing to have in practice because let's say you're migrating from one embedding model to the next. You don't have to try with lots of different tables. You just have the same table and add another column to it. All right, that's it for hybrid search. As always, when we're done, let's drop all our tables and let's drop our database. We're just deleting them here. Oh, shoot. I just deleted the cell instead of our data. Okay, now I'm done. All right, thanks so much, and I'll see you in the next one.